Can an EC fan make a hospital room, office, or apartment quieter? Sometimes, but EC is not a decibel result. A credible comparison must hold airflow, pressure, installation, and measurement method constant. Otherwise, a lower number may simply mean the fan is doing less work. Start with the operating point. Put the AC and EC candidates at the same airflow and static pressure, with the same inlet, outlet, guard, duct, and mounting. Record speed, power, control command, and air density. If duty is not equal, the acoustic comparison is not equal. This Longwell source clip shows a real fan test arrangement with a microphone beside the running assembly. The current exact model sheet lists 85 dB, A, as LPA, but its visible nominal data row does not state microphone distance, background correction, the acoustic operating point, or uncertainty. The clip itself shows no traceable meter result. These are useful pieces of model and geometry evidence, not a universal comparison by themselves. Next, separate sound pressure from sound power. Sound pressure is what one microphone reads at a place. It changes with distance, room reflections, and background noise. Sound power characterizes source emission under a defined method. Do not compare an in-room dBA reading with a laboratory sound power rating as though they were the same quantity. A single A-weighted number can hide the reason a fan sounds annoying. Keep the octave or 1/3 octave spectrum. Low-frequency blade passing content, motor tones, switching tones, and broadband turbulence need different remedies. The quietest total number is not always the least noticeable spectrum. EC control can reduce noise when the system actually needs less duty. Lower rotational speed often reduces aerodynamic excitation, and electronic commutation avoids some motor frequency mechanisms. But an EC motor cannot rescue a fan operating near stall, behind a restrictive guard, against a sharp elbow, or with severe inlet swirl. Watch the aerodynamic path. Inlet distortion reaches the wheel once per revolution, blade interaction creates tonal content, separation and leakage create broadband content. Match the wheel, inlet clearance, and housing to the required point before choosing a control signal. Then trace structure-borne noise. Motor force travels through brackets, panels, and ductwork, where a panel resonance can amplify it. Isolators, stiffness, and mass must be selected for the forcing frequency and load. Soft mounts are not a universal fix, and they must not compromise alignment or safety. Distance matters for field checks. In a simple free field, doubling distance from a compact source can reduce sound pressure by roughly 6 decibels, but rooms, ducts, and nearby surfaces break that approximation. Always report microphone location and environment. Multiple fans do not add by ordinary arithmetic. 2 independent equal sources add about 3 decibels, 10 add about 10. Control strategy can exploit this, distribute duty, avoid unstable regions, and prevent synchronized tones, but validate the complete array and its structure. For a real comparison, calibrate the instrument, document background noise, lock the airflow and pressure point, define inlet and outlet configuration, record distance and microphone positions, retain band spectra, and repeat the run. Current laboratory routes include ISO 13347 and ANSI AMCA 300, selected for the setup and claim, and used by qualified test personnel. The decision package is simple: exact fan and controller, duty point and range, installation category, spectrum and overall level, sound quantity, weighting, test method, uncertainty, and raw evidence. That package tells you whether an EC option is truly quieter for the application, not merely quieter in a marketing clip.